Now this circuit contains a capacitor. It has two resistors and a battery. Initially circuit is open. That is, there is no current inside this circuit. At t is equals to 0, this circuit is closed. We have to find potential difference across this capacitor as a function of time. Now may remember formula Q is equals to CV, where Q is the charge on capacitor, C is the capacitance, and V is the potential difference across the capacitor. Now this means if I can calculate charge as a function of time, we can calculate potential difference as a function of time. That is, V is equals to Q by C. So we are interested to find charge as a function of time. Let us redraw this circuit again. Let us say battery sends a current I. When this current reaches here, it is divided into two parts. Let us say this section has a current of I1 and this section has a current of I minus I1. We have to follow the junction rule, that is total current coming is equals to total current going, that is I is equals to I1 plus I minus I1, and that is equals to I. So we have basically followed the junction rule at this point. Now this is the direction of positive current, so we will have positive charge on this plate and negative charge will develop over this plate. Let us say at any time charge is Q. So current through this section is I1 and through this section is I minus I1. So when these two currents reaches here, they can combine and finally we have a current of I. So battery gets a current of I. That is, battery remains neutral. The current given by the battery is same as current taken by the battery. So battery remains neutral. Now we have three unknown, I, I1 and Q. We can write three equations to solve this one. First equation we can write, that is dq by dt is equals to I1. And rest two equation we can write from this circuit and from this circuit. So let us write one equation from this circuit. If I start from here, so I am going from lower potential to higher potential, so we will have a plus sign. And here we are going along the direction of current, so we will have a minus sign. Again we are going in the direction of current, so we will have a minus sign. That is same as so from here we can calculate I, that is equals to xi plus I1R divided by 2R. So let us call this is equation 2. Now we can write one equation through this circuit. So let us start from here. I am going from positive terminal to negative terminal, that is higher potential to lower potential, so we will have a negative sign, and potential difference across the capacitor is Q by C. And here I am going opposite to the direction of current, so we will have a plus sign. So this is third equation. Now we can plug the value of I from equation 2. So we can have simplify this one. R gets cancelled. So we will have so we can find I1 from here. Or we can write I1R is equals to xi minus 2Q by C, or I1 is equals to xi by R minus 2Q by RC, and I1 is nothing but dQ by dt. So we have this equation. So we can take RC LCM. Now we can separate the variable and perform integration. T is equals to 0. There is no charge on the capacitor. And T equals to T, let us say charge is Q. So we will have so this integration becomes and we can write minus to this side. We can also write in terms of e to the power So we can further simplify. So from here we can find Q. So this is equals to 2Q. So Q is equals to IC by 2 1 minus e to the power minus 2t by RC. So this is the charge on capacitor at any time t. So we can calculate potential difference across the capacitor, that is Q by C. So this becomes xi by 2, C cancels out, 1 minus e to the power minus 2t by RC. So this is the potential difference across the capacitor as a function of time. So potential difference as a function of time. Now from here one can see at t is equals to 0, potential difference is 0. So if I plug this value 0, this becomes 1. So 1 minus 1 is 0. So potential difference is 0. And when t is infinity, this term will be 0. So potential difference is xi by 2. So basically we can plot a graph, potential difference versus time. Potential difference on the y-axis, time on the x-axis, and maximum possible potential difference is xi by 2. So we will have something of this kind of graph. Similarly, one can plot charge on capacitor as a function of time. Same thing. So we have Q is equals to xi c by 2, 1 minus e to the power minus 2t by RC. So let me check. This is minus 2t by RC. When time is 0, there is no current on capacitor, that is Q is equals to 0. So if I put t is equals to 0, this term will be 1. So we will have charge is 0. When time tends to infinity, charge tends to xi c by 2. Because this value is 0, so this becomes xi c by 2. So we can plot charge versus time graph. Maximum possible charge is xi c by 2. And this will be as asymptotic. So graph will be something like this. So this problem illustrates how to write circuit equation, and once we have written the circuit equation, we can solve the integration to find charge as a function of time and potential difference as a function of time.